Hello, everyone. My name is Johan. I'm one of the TAs in the course. So soon you will get your quadrotors distributed. But before that, we will have a small tutorial of everything you need to know, the practical stuff, for you to be able to develop controller code and everything for the Crazyflie. So that's probably the first half of this lecture. That we will spend some time on that. So you can develop the code for the Crazyflie in a few different ways. The one that we support is through a virtual machine that you can download. So you will download this software called VirtualBox, and then you will download a finalized virtual machine from the Bitcraze website. So we provide you with links for all that in the ping pong page. And then you will just start it up, and then you will have a virtual Linux machine inside your computer, and it will work no matter if you're on a Windows or on a Mac or whatever operating system you're using. And then all the settings and everything will be exactly the same, regardless of your own computer. So, and also all of these instructions, or most of these instructions, are available as a README on the course webpage. So on the course webpage, if you go to the project introduction or the project meeting 1, then there is a link to this README file here, which is a PDF file where you have step-by-step instructions of most of the things that I'm going through here today in this tutorial. Right. So you download VirtualBox, you download the virtual machine, you go into import appliance, and then you find the virtual machine that you just downloaded and select it, and you press OK. I've already done this because it takes a few minutes, so I didn't want to waste any time on that. But then it will get the name Bitcraze VM, and you can start it if you like. So I haven't started this one yet. This is fresh downloaded from the Bitcraze website. And what you need to do before you actually start it is you need to change a few settings in it. So you need to go to settings, and then in the USB you need to change USB 2.0 to 1.1. And then you also need to share a folder. So on your computer, you need to just decide on a folder where you want to keep all the code and everything that you develop for the Crazyflie. And whenever you have that folder, you go into settings here, and you add that folder as a shared folder. So you select some folder, and I already have a folder which I know where I want to develop these things. So I'll just go ahead and find that one. There, and then you press also auto mount. It's very important, and it's also in the README. So then you press OK, OK, and then you press start. And then you will boot up the virtual machine for the first time, which takes a little while. So in the meantime, we can look at how you will get the basics for what you need to develop your code. So we will distribute it through what's called GitHub Classroom. I don't know how many of you have heard of Git, but it's a way to share software with the other people in your group. So if you make changes by yourself, then you can still merge them together, like upload your changes, and Git will automatically make sure that your changes are all kept. In case there are some conflicts, you will have to fix them, but it's a convenient way to develop software shared in a group. So there's also a link in the README to some tutorials if you need to know like what Git is, and you need to know a few of the basic commands of Git to be able to develop in it. But otherwise, you don't have to learn much about Git itself. So what you actually do to get started in your groups is that you visit this link. It says to get started, visit this classroom.github link, and then you will create a group there. So each group will have a team in the GitHub Classroom page. I have already created a test team for myself, so here it says you're ready to go, but you yourself will call your group the same group number as you have in ping pong, so that we can keep track of everything. And then you will get a link to your assignment, and that's a Git repository, so it will look something like this. And that's kind of all we need to know for now, and then in a few minutes I will show what you need to do with this. So this is inside the virtual machine that I started up. This is how it looks for the first time. It will prompt you that a new version of Ubuntu is available. You don't want to upgrade that. Okay. There's also a button here on the desktop which says update all projects, which is basically it's a bitcraze link or a shortcut on the desktop. So never ever press that one. If you press that one, then you will have to download the virtual machine again and start over from scratch. So no matter if you see it on the bitcraze website, you might see that they want you to click on this update all project, but you shouldn't do it in this course. So inside here, if we open file system, now what we don't want to do in this virtual machine here is that it's its own operating system, but we shared a folder to it. So there is a shared folder, which in my case is called tutorial. So if we make changes in it in our main computer, so in my case it's a Windows computer, then the changes will show up also inside the virtual machine and vice versa. So that's why we share it. So if we try to go into that folder right now, then it will say that we don't have permission to do that. So then you open up a terminal. You can double click the terminal emulator on the desktop. And then you write this, sudo add user bitcraze vbox sf. And then it will prompt for a password, and the password is crazyfly. Great, so then that's done. When that's done, you need to log out and then log in again for the changes to take effect. So this is for you to be able to actually get into the shared folder inside the virtual machine. And there are a lot of instructions now, and most of the instructions you don't really need to understand what they do, but you need to do them in order to be able to develop the software for the project.
Are the instructions also on the ping pong side, on the README?
Yes, all these instructions are in the README. Yeah. And if there's some step that is unclear, you can always send an email to us and we will clarify it in the document. But we have clarified the documents in several iterations through previous iterations of the course, so hopefully it's good enough. So when you want to log in, then again the password is crazyfly to the virtual machine. Right, and now you also want to open the terminal once again, and then you write this cryptic command. Well, it's so cryptic, so I actually want to copy it from the PDF here. So let's see here. So it's this command here that I want to copy. And you don't need to understand what it does, you just need to do it. So you need to copy the command and put it into the terminal in the VirtualBox. To be able to copy, you need to go into Devices, Shared Clipboard, and then you select Bidirectional. So that's if you copy something in your host operating system, then you can paste it inside the virtual machine. So now that I've done that, I'm going to copy this. I go in here, right-click, paste, and then we have that command. I press enter. I type the password, which is crazyfly. And then it asks me if I want more disk space to be used. I type Y, and press enter. Then it installs a package which we will need. And then, so that's fine. It's finalized. We can close this terminal. And now with that out of the way, we can actually go into the shared folder. So if you open File System, then you go into, so in my case it's called tutorial. So now what you want to do is, if you go to this Git repository that you got the link from the GitHub Classroom, if you visit the link in the README, then you will get this page. There's a green button which says clone or download. So you can just copy this link that you have here. And then you move into the virtual machine. You go into your shared folder. You right-click, you press Open Terminal here. And you type git clone and then -- recursive, and then you paste what you copied from your Git repository. And then you have to type your Git username and password. And then it starts to download all the things that we've prepared for you in the course. So this will take a little while, probably a couple of minutes. There's some files that you need to have. So in your case, you will get a folder here which is called Quadrotor Lab and then Group XX, where XX is your group number in ping pong, since that's the way that you will name your teams in this GitHub Classroom thing. So if you go, so this is inside my computer now, my Windows computer, and then if I go into this directory here, which is called tutorial, then I can see that this folder has shown up here as well. So the thing is that inside the virtual machine, then you have Git, for example, and you have the crazyfly client, so you can actually connect to the Quadrotor that you have, but you don't have MATLAB. So in this course, you will design things in a model-based way in Simulink and MATLAB. So that's why we have this shared folder, so that in your host operating system you have MATLAB installed, and when you download this starting kit using Git, you will actually inside here get some Simulink models. So that's what you need to develop. You develop the things in your host OS, and when you're finished with that, you generate C code using Simulink. Then you go into the virtual machine, and from there you will upload the C code to your Quadrotor. So you will work in both your host operating system and the virtual machine. So the files that you will get when you do this git clone, they are developed in MATLAB 2016b. So anything earlier than 2016b won't work for you to have. So you need to update your MATLAB to a newer version if you have an older version than 2016b. You can have a newer version if you like, but the most convenient is if everyone in your group has the same version of MATLAB. Because otherwise the ones that have older versions of MATLAB, they won't be able to open files that have been edited by the ones that have the newer version of MATLAB. Yeah, you can export it, so it's still possible to do it, but if you just save it then you won't be able to open it. So I'm just saying the most convenient thing is if you make sure you have the same MATLAB version, but you don't have to do that. So now it is finished. So it's done with downloading all the files that we have created for you. So we can have a look inside this repository and see what this folder actually contains. So there is one folder called Crazyfly Clients Python. You don't have to care about this folder. It's basically just some dependencies. So it contains packages in Python that you will need to run different things that we have created. So you never need to go into that folder. The other one is called Crazyfly Firmware, and that's where you will actually change stuff. So if you go into here, the interesting folder here is the one that is called Simulink Model, because that's where all the Simulink files are. So it's probably more convenient if I go inside Simulink Model here in my Windows OS. So you see three different Simulink models. One that is called closed loop, one that is called Crazyfly, and one that is called open loop. So if I open one of them in MATLAB, we can open the closed loop system. Then you have some. You also have some Simscape files. So you have one Simscape file which you need to take into account, which is called plant.sse. So the closed loop system is a simulation of your controller together with the plant model, and we also simulate the sensors, but that's none of your concern. So this is how the closed loop model actually looks. So there are three main parts, you can say. So here to the left, it's where you actually define your reference for the quadrotor. So there are four input signals for the reference. It's for the base thrust that you put in here. And then you put reference values for the roll angle, the pitch angle, and then the yaw rate. So not the yaw itself, but the yaw rate. And you can define, we have made it so that you can either define constants here, or you can flip this switch and you can define inputs by yourself in the MATLAB workspace. So the simplest thing is to just change the values of these constant blocks that you have here. So you can double click them, change the value, and then the references will go into your controller block here. So this second block here, which is the controller, if you double click this one, it will actually open another Simulink model, which is this Crazyfly model that we found in the same folder. So this is how the controller looks right now. You have access to the controller input, so these four reference values. You have access to the sensor data from the accelerometer and the gyroscope. And then what you want to do is you want to create some controller here using Simulink blocks and send outputs to the motors. So the outputs that you send here are converted to unsigned integers, 16 bits. So it will be a value in between 0 and 65,536. So a value of 0 means that the motor will be off. And if you put all the motors on maximum 65,000, then it will be able to lift approximately 60 grams. And then you also have these outputs here, which are for logging signals. So it's basically when you are in the virtual machine, you will be able to open a Crazyfly client so that you can see the values of everything that you have to your connected Crazyfly. And then you can select specific signals. For example, if you try to estimate your angles, then you can drag them to these logging outputs here, and then you will be able to plot them in the Crazyfly client. And I will show you how this works in a little while. So it's very convenient, for example, to plot some angles that you have estimated, and then you want to show these plots in an assignment report or something like that. So continue. So that's the controller block in this closed loop system, and the last part is the plant model then. So what you have here is the Simscape file, so the Simscape plant. So if you double click on this one, and then you press source code, then you will open this plant.ssc file. So here is, you can say, a code skeleton of what you should model when you model your quadrotor later on. So we have defined some constants here for you, so that you don't need to figure them out yourself. But all the equations that determine how you simulate the quadrotor, there are no equations as of now. Everything's just set to 0. So this is what you need to model here. And then the final part of the closed loop system, that's the sensor block. And that's not something that you can edit, and you don't really have to care about it. What's important for you is that you get the accelerometer readings and the gyroscope readings from it in the simulated environment. So you can see that there are also a lot of scopes everywhere, so that if you run a simulation and you want to check if it makes sense, then you can check out all of these different scopes to try to find, if you have an error, then you can find where the error is. Right, so now we have everything in a shared folder. We have access to it from the virtual machine. We have access to it from our host OS, where we can edit it in MATLAB. So let's create some simple controller and see if we can make it work in this quadrotor that we have here. So for your first assignment, we want you to make just a simple P controller, and you're supposed to implement a complementary filter so that you can estimate the angles coming from you go from the sensor readings to estimating the actual angles, and then you're supposed to make a P controller from that. So there are more detailed instructions in the ping pong page. But what I'm going to do something simpler. I'm going to try to make a P controller on the roll angle. So basically, if I tilt it one way, I want the motors to activate to try to flip it so that it's stable. And if I tilt it the other way, then these motors will activate and it will flip it back. And I will do this in a very simple way. So instead of having a complementary filter, I will use a discrete time integrator. So in here, everything is discrete when we want to generate the code for this. So I have a discrete time integrator from the gyroscope X reading. So this will be an approximation of the roll angle. I add some gain. So let's make that gain 3000, because we need some high numbers for this motor, which goes between 0 and 65,000. And I'll add a minus sign to some of the motors, because I know how the motors work and which motors I need to have a minus sign on the input to make it activate in the correct direction. So this is also part of the first assignment for you to figure out in which direction, when you tilt in a specific direction, is that a positive roll angle or a negative roll angle? So all the frames of the quadrotor that we use here, that's part of the first assignment. So also, apart from just implementing this super simple controller, I want to log this estimated angle that I'm estimating from this discrete time integrator. So now I feel that, okay, I'm happy with this prototype of my controller. So this is, of course, very much more simple than what you need to do for your first assignment. But when you're happy with your controller, Then you save it, and then you press this button up here. So it's, and it says build model. So you press that one, and then Simulink will work for a while. And then we get some code generation report, and everything was fine, so we say okay. So now we're finished with what we want to do in the host operating system, in the Windows operating system. Now we have generated the C code that we need. So then we go into the virtual machine, we go into the shared folder, into our generated Quadrotor lab folder. We go into Crazyflie firmware. So when you are in Crazyflie firmware, you right click, you open a terminal here, so you can close the old terminal that we had. And when we are here, we type make, and then enter. And then it will work for a while. Are there any questions so far? So I know there's a lot of steps, but all the steps are detailed in the README, so you don't have to be scared if you don't remember something specific. This is just so that we have this tutorial so that you can see how it's done when it works. Hopefully it works when I do this, so that you know that it can actually work. Some of you will have problems with specific parts, and you can get some errors. And if you get errors that you can't fix yourself, then you contact us. And likely it's an error that we have faced before, or you have missed some step, and we can help you with that. Right, so now it's finished, and so it took a couple of minutes, and it's only the first time that you do this make command that it actually takes a couple of minutes. Every subsequent time that you will do it, it will finish in like 10 seconds or something. So what we basically did was that we made all the code ready for deployment to our Crazyflie. So what we want to do then is we want to start this Crazyflie in bootload mode. Basically that we want to make it ready to receive packets. So if you just press the start button once, then it will start with basically all the control code that's already in it from the start. But we want to change the control code that is in it. So we hold the start button for a few seconds until these blue, there are two blue lamps, until they start to blink. So when they start blinking, then we know that it's in bootload mode, and it's basically listening for commands to come from a computer to upload code to it. So you also have a USB dongle like this that you will connect, which is a Bluetooth antenna. So you connect it to your computer, and then you want to use it to upload the code through Bluetooth to your Crazyflie. So the way you do that is in the same terminal where you just type make, you instead type make cload like this. And so if you press enter now, then it won't work, because it says it cannot find a crazy radio dongle. So then you go down in the bottom right of the virtual machine, where it looks like a USB. You right click that one, and then you press bit crazy radio PA USB dongle. And then you go back to the terminal and you type make cload, and then it should work, hopefully. Right. So now it says it started to flash the software to our Crazyflie, and we can know that it's actually doing that because now there's a green light that is blinking very quickly. It looks like it's shining because it's blinking so rapidly, but that's how you know that it's actually transferring data right now. So it should soon be done, and then it will have my new controller code in it, so it's a good idea to hold it in place somehow. There's been a lot of incidents with group who just leave it be, and then they upload some bad controller code, and then it flies up into the ceiling, and they have to wait for 10 minutes for the battery to die. So now it has the controller code in it. So the first thing that you need to do is that it needs to stand on a flat surface. So there will be a red light that blinks slowly, and this is during the sensor calibration. So every time you start it, it will calibrate its sensors. So the controller code in it hasn't started working yet. And then when the red light starts blinking at about twice the pace, then the sensor calibration has finished. So now this Crazyflie is running the code that I made earlier. So if I tilt it one way, then those motors will activate, and if I tilt it the other way, then those motors will activate. So it actually tries to adjust for the error that I'm introducing in the roll angle. So another thing, okay, we got the code working on the quad rotor, and that's great. But then you also need to be able to show your results. As I said before, you need to show graphs of, what you tried to accomplish. And how we do that is on the desktop in the virtual machine, there is a shortcut called Crazyflie Client. So if we double click that, then we will want to use that to connect to our Crazyflie. So it looks like this. It says not connected, but then basically what you will do for all your Crazyflies is that when it's out of the box, it will send data on channel 80. So you scan for Crazyflies, and then in this list you will see like the Crazyflies that it managed to find. So in my case here you will see 80 in the middle. So it says 0/80/250K. So 80 is the channel that it's sending on. So you want to connect to that one the first time. So now it's actually connected, and you can see that because there's a green light here shining again, saying that it's connected. And also, if you look to the bottom right, then you will see the current motor speeds that I have. So if I tilt it, you can see that some motors go up. If I tilt it the other way, the other motors go up. So you can check that, okay, it's actually connected here. Now the first thing that you should actually do when you connect your Crazyflie for the first time is that we don't want everyone to send on channel 80, because that can be quite confusing if everyone sits in the same room during some consultation hours, for example. So then you need to you connect to it, then you press the connect button, configure 2.0, and then on the radio channel you will change the channel to be your ping pong group number, so that every group has their own channel to send on, so we don't get too much interference. That's also in the README. And I want to restart my Crazyflie now because it starts to drift too much. So every time you start it, you wait until the red light starts blinking more quickly, because then the sensors have finished calibrating, and it needs to stand still to do this. So do not start to like lift it and check it before the red light starts blinking more quickly. Usually takes a few seconds. It can take up to 10 seconds. So sometimes you have to be a bit patient. Okay. So let's imagine now I changed the channel for my quadrotor to my ping pong group number, and that's great. So now let's check what do we do to get access to the log blocks. If you remember, I sent my integrated gyro X angle to the log block in the Simlink model. So what we need to do then is we open here, we say view, and we look at the tabs that we have. So currently we have one tab, it's called flight control. We want to add a few other tabs. We want to add log blocks, and we also want to add the tab plotter. So those are the two tabs we want to add. Then we go into settings and we check login configurations. And so in the login configurations, you scroll down to close to the bottom, and then you will see a log group here called Simlink. So then you have 6 log signals. It's exactly the 6 log signals that you saw in the Simlink block earlier. So then you can move them to the right with this arrow. You must decide on a logging period. Let's say I wanted to update 10 times each second. So the logging period is 100 milliseconds. I call this logging setting tutorial, and then I press save. So then we go into this log blocks tab that we just created. So we move from flight control to log blocks, and we uncheck everything except the one that I just created, which is called tutorial, which has these Simlink log signals. And then you go to the other tab called plotter, and in the plotter you select tutorial. So then if I tilt it, then you can see that this green line here shows the estimated integrated angle around the roll. So if I flip it out to the 2 different directions, you can see that it's an estimation of the current roll angle of the quadrotor. So typically what you want to do then is you can right click and then you can press export, and then you can export this graph as a PNG file, so you can include it in one of your reports, for example, when you want to show different files. So you can connect anything that you want to show, you connect it to the log block in Simlink, and then you plot them, and then you show it to us in a really nice and neat way with informative access information and good labels. So that will be really nice for everyone involved. Also, even though it's actually standing still on the table, the motors are on, and we can see this is because it seems that the angle is not estimated very well. As you know, because Knut has told you that, and maybe you knew it before, it seems like the angle is drifting. So we have integrated drift here. And that's why you should implement a complementary filter that does something better than just integrating the gyro. Okay, so then if you want to change something again, then you go into your host OS, into MATLAB, you open this Crazyfly Simlink model, and then you change something in your controller. Maybe you log some more signals, you save it, you press build here, you go into the virtual machine, you type make, and then make cload, and then it will work again. And that's kind of the workflow here. So you will switch between your main operating system and the virtual machine. Back and forth.
How do we see graphs in MATLAB?
Sorry?
Can we see graphs in MATLAB? And how do we do that?
You mean when you simulate it?
Yeah.
Yeah. So basically you just, if you want to simulate closed loop, and you can also, so when you develop your plant model, I actually didn't mention that one, but there is this model called open loop. So where you just simulate the plant. So this is what you want to simulate when you model your plant. Then you do, it's just a nuisance to have to design a controller as well, right? So in that case, you design or you create your equations inside the Crazyflie Simscape file, which you can open if you double-click this one and press source code. And when you've done that, you can just simulate this open loop system.
Didn't we need some sensor data coming? Is it coming?
Yeah, that's when you design your controller. So this is for this is when you model the plant, and then you don't really care about the sensor data then. You just want the plant to be as correct as possible. So then you can simulate it and you can check the scopes, and then you can check that your signals seem accurate. So in my case here, all positions are 0 and everything is just 0 because that's the way it's set from the beginning, because we don't give you any information about how the equation should look. But when you change things, then you can see, for example, a reasonable thing, if you don't give it your Crazyflie any input, it should probably just fall straight down. So you can check this by opening this position scope here and see that one of the 3 signals, it starts to go down. So that's what you will want to do. And then when you have designed your plant model and you're happy with that, then you can simulate the closed loop behavior. And so here you will take the sensor data, and the sensor data is already connected back to your controller block, and then you open your controller block, and here's where you add your controller code.
But like when we're simulating, is it coming from real time from the Crazyflie, or?
No, when you're simulating. So everything is just inside MATLAB. So there's no connection then to this. No. And the sensor data that we have here, it's simulated sensor data. So everything, all of this is just simulation. So you design your controller and see first if it works reasonably well in simulation. For example, that you have the correct signs on everything. You don't have like a flipped minus sign somewhere. And then when you're happy and the controller works well in simulation, well then you can build the model and you make it and you load it to your Crazyflie from the virtual machine.
What kind of sensor data we have? Like it's already uploaded inside, or?
Yeah, so the sensor data, you have the accelerometer and the gyroscope.
But like it's already pre-filled numbers. Like what actually we're getting into our
yes.
controller.
Yeah. So
we're not connected to the device. Where the data came from?
Simulating it.
It's through simulation. We just simulate it. So you create a plant model and you fully simulate it, and then we have this sensor block here which simulates the sensors. So everything is purely simulated. So nothing in here comes from the real system. But from here you design your controller based on the simulations, and later on you will design controller based on your plant model. And then you will build C code based on this, and the C code will be transferred to this real system, and then you will run it on the real system. But as long as you're here in Simulink, then everything is simulated, so there's no real sensor data, and the sensor data is just, what you have available to use as signals here. You can see the accelerometer, it's the unit is here, and the gyroscope angular velocity, the unit is here as well, so you have all the information that you should need to design your controller. Are there any other questions or something else that is unclear? Because otherwise then I think this tutorial is concluded. You have the README available on the ping pong page, so you can follow all the steps there. If you have any trouble, then you can contact the TAs by email. And I guess we will have a break, and after that we will hand out the Crazyflies. Yes? So, yeah, I guess 15 minutes breaks is as usual.